40-point quiz on all those kinds of problems on Monday. I'm just telling you now. Not what I'm going to start today. That'll be on the next test. Now, is there anything for now? I mean, you can still do this tomorrow. The quiz is Monday. 40-point quiz on all those exponent problems. The 3 assignments you got back, that's what the quiz is on. Is there something that somebody has a question on that I've done the last 3 days? Because I'm going to start something new here today. This is something that you have not seen before in a math class. So those answers are all there. I suggest, you don't have to do it this instant, but I suggest you check all those answers. Because if you're making mistakes or screwing up, I'll help you tomorrow. You can ask me tomorrow. I'll just save it for tomorrow. Okay? They're all there. Is there anything off the top of your head you have a question on? The first 2 assignments were easy. Yesterday was the same rules, but they were just a little bit more involved. You had a few more steps to do. What do you do when you have a big fraction grouped with a negative power attached to it? That came up a lot yesterday. What do you do when you have a big fraction grouped with a negative power attached to it?
You
Flip it, and then it's to the positive power, and then you continue from there using all your rules. Fellas, this is the only way you can kind of screw up a quiz like this. You know, sometimes you add the exponent, sometimes you multiply the exponent, sometimes you subtract the exponent, sometimes you distribute the exponent. Those are all the rules I gave you Monday. Don't mix them up. You got to know when you're adding, you got to know when, and you got to know when you're doing all that. Okay. All right, you can put your iPad aside for now. I strongly encourage you before Monday to check those answers. Probably didn't get through checking all those right now, but that's okay. If there's anything you need to bring up to me about this quiz, you bring it up tomorrow, first part of the period. Okay, now go to a brand new page in your notebook. Pay attention. This is new. What I'm going to go through. Just put your iPad aside. This is March 9th, Thursday. Here we go. If the nth root of A is a real number, I'll mark this down. Here's the first definition that I'm going to give you. Now, I told you what I was going to cover here today. The last 3 days in here, what kind of exponents have you seen? 0 exponents, positive integers, or negative integers? Now I'm going to give you the definitions for when you have fractions for exponents. So here's the first definition. A to the 1 over n power, now get this, and I'll show you the little examples, means the same as the nth root of A. Now there's the first definition. Now you guys, when you think about everything we did in trig, you were working with radicals all the time. I mean, my God, so you should be so familiar with radicals. See this little n that's here? What's the purpose of that little number there? On a radical. See how I have the nth root of A? What's that little number there tell you? Oh, wow. Hey, by the way, you guys got to get better. Yesterday was horrible in here. I can't be the only one talking all the time. So let's cooperate a little bit better. Wow. I ask questions sometimes. I can't believe I can't get the answers out of you. This little n, what's that little number telling you? It's telling you the what of the problem when you have a radical. Jack? No, not a power. What if that's a 2? What does that mean? Now, you by the way, you would never see the 2 written on a radical, right? Rob?
If there was a 2, it'd be square
the root. That's the index. That's called the index there. That little number is called the index. The purpose of the index is it tells you what root. So if that was a 2, it's a square root. If that was a 3, it's a cube root. If that was a 4, it's a fourth root, etc., etc., etc. That's radical form. This is exponential form. A to the 1 over n is the same as the nth root of a. Now, I'm going to start putting some little examples up here. Now write these down. These are going to be very fast problems. We'll start with this. Now, like I said, in your years of math so far, you have never seen problems with fractional exponents till now. All right, let's start with those. This is the first time now you've seen this in algebra. Now, again, I'm just going to keep this. Tomorrow I'll go into it more. Today is just the intro to all this. When you have a fraction, 1 over something, if it's to the 1/2 power, it means what kind of a root? Now, there's the definition. If you have anything to the 1/2 power, it means the same as what as far as a radical goes? There's the definition. All right. If you have something to the 1/2 power, you see the denominator? See the denominator is the n? What's that denominator telling you? The root. See what I'm saying now? The denominator is telling you the root. So if the denominators are 2, it's a square root. If the denominators are 3, it's a cube root. If the denominators are 4, it's a 4th root. Okay, you with me now? So this says 25 to the 1/2 power. What does that basically mean the same as far as a radical goes? This is how you have to start thinking now. And you want to know why? A lot of people says, why are we doing this? Well, I'll tell you why. And Mr. Sitek will tell you. Because that's who's probably teaching Calc Honors next year. Fractional exponents come up a ton in Calc. That's why you're learning it this year. Because you'll see it when you do calculus next year. Joe?
Square root of 25.
That means the same as the square root of 25. Anything to the 1/2 power means it's a square root. So that's 5. I mean, that's done. That's a one-step problem. 25 to the 1/2 equals 5. But the way you have to think, when you see that, that means the square root. Now, okay, I'm not going to say anything. How do you think you would write the answer to the second one? I don't want to say anything. I want to hear what you tell me first. 3 to the 1/2 power would mean the same as what? Chris?
Radical 3.
3 is not a perfect square, so it's square root of 3. 64 to the 1/3 means the same as what? Look, the denominator tells you the root. If it's a 3, it's a cube root. Now, do you know your perfect cubes? I would hope you do. Isn't 64 a perfect cube? Doesn't 64 to the 1/3 mean the cube root is 64? What's the answer to that? See, that you should know that, you guys, like memorized, because it's perfect. Rod?
4.
4 times 4 times 4 is 64, right? Look at this one. It's a fraction. So, 1/8 to the 1/3 means the same as what? The cube root of 1/8. What's the answer? Isn't it perfect? So what if it's a fraction? You know 8's a perfect cube, right? You got to know your perfect roots, boys. Noah.
1 minute.
Good so far? I mean, it's pretty basic so far. I mean, I got more to show you here. Now, how smart are you? Now, you got to be smart here. Because I don't want to say a word. I don't want to say a word here. I want to see if you can give me that. Careful. What do you think the answer to that last one is? Be careful. Follow your rules of order of operations. Brandon.
It says 4i.
No. No. Nathan?
Negative 4.
And I'm going to tell you why. Do you see any parentheses there? You do not. So why don't we write this right underneath it? Now you see that problem I just wrote? That's a different problem, because it's grouped. This says negative 16 to the 1/2. This is saying, what's the opposite of 16 to the 1/2? What I'm saying is, don't you always do exponents first? So isn't 16 to the 1/2, square root of 16 is 4? The opposite of 4 is negative 4. Now, come on, you guys. Freshman algebra. What do you think the answer to that one is underneath it? We're in a set of real numbers, by the way. So that's not the answer. That's good what you did to us. Okay, but we're in the set of reals. Doesn't this mean the square root of negative 16? First, you understand what it means, right? What is the square root of negative 16? Come on, think about what I just said. We're in a set of real numbers, by the way. What is the square root of negative 16? By the way, what's the square root of any negative number? Oh man, come on, you guys should be able to tell me this. What's the square root of anything that's negative in the real numbers? Howard?
It doesn't exist.
Doesn't exist. Do you understand that? Can you give me a real number times itself that would equal a negative number? It's impossible, isn't it? So, in this situation, you have the square root of a negative number. This is what you write down. Now make sure you're getting this. Those are the words you got to write down. See, Brandon, and you guys that had me in freshman honors, which is most of you, he said 4i. That's right if you were in the complex numbers, imaginary numbers. But did you hear what I just said? We're in the set of reals. So if we're in the set of reals, this is just a no real root. Okay, now watch. I'm going to take this to the next level now. Here. Write this down. There. Negative 32 to the 1/5. All right, maybe we should go off to the side here for a minute. Two is a perfect fourth root of what number? Let's see if one of you can give me that. Now, when I say fourth root, that means the same number multiplied 4 times. Gives you a certain number. 2 is a perfect fourth root of what number? Now, you can just do that in your head, you guys, because 2 ain't that big. Alex?
16.
You understand that? 16 is a perfect fourth root because 2 times 2 times 2 times 2 gives it. 2 is a perfect fifth root of what number? Just take it one more time. Rob? 3 is a perfect fourth root of what number? Now, in your head, just multiply 3 4 times. 3 is a perfect fourth root of what number? Ethan?
81.
81. 3 would be a perfect fifth root of what number? Now, just take it one more time. 3 would be a perfect fifth root of what number? Jack?
242.
Now, you might want to make a note of this or just remember it. These are some higher roots that you should be familiar with. Square roots and cube roots you should already know. All right. Look at this right here. Negative 32 to the 1/5. Doesn't that mean the same as the square root of negative 32? Right? Here's your property, how I started class. Somebody? Doesn't this mean the fifth root of negative 32? You with me? The denominator tells you the root. And I just gave you these roots over here. What's the matter? I gave you the higher roots over here. I mean, it's there. What's the fifth root of negative 32? Jimmy?
No real root.
No.
Well, what's the difference between?
I'll tell you the difference. The difference is this is odd. This is even. So let me clarify. An even root of a negative is no real root, but not an odd root. Here, let me ask you this. What's the fifth root of 32? Somebody. What's the fifth root of 32? Ethan? 2. What's the fifth root of negative 32? See, there's an answer when it's odd. What's the fifth root of negative 32? Andrew? Negative 2. Think about it. If you multiply negative 2 5 times, won't you get negative 32? Because it's odd. Not when it's even, though. Look, watch this. See that? Negative 81 to the 1/4. What would you write in a test for that? What would you write in? I just made that up. Negative 81 to the 1/4. How would you answer that? It's an even root. Wrong. That's no real root. Because it's even. But if they're odd, it has answers. Okay, let's come over here. Write this down. 8 to the 2/3. All right, now this is the second part of today, and then I'm going to give you problems like this. What's different about what I just wrote on the board compared to all these other ones I just did? Just tell me what's different. What?
Numerator's not 1.
That's right. There's a number on the top. Okay, now watch this progression. Write that down. Just look what I did. I'll explain why in a minute. I rewrote 8 to the 2/3. Now, all those rules of exponents you've been using the last 3 days, they all still apply, everybody. They all work. Isn't that a power to a power? What do you do when you have a power to a power? Multiply, right? Isn't 1/3 times 2 2/3? Do you see why those are equal? Okay, now watch this. Right here. What does 8 to the 1/3 mean as a radical? What does 8 to the 1/3 mean as a radical? After everything I just did here. David.
2.
No. I want you to write it in radical form first. I don't want the answer yet.
3 radical 8.
No, you're saying it wrong. Don't give me the answer. Rewrite it in radical form. See 8 to the 1/3? What does that mean like this in radical form?
Radical 8.
Cube root of 8.
Cube root of 8.
Cube root of 8. Look. Cube root of 8. Do you see how this means the same as that? And then let me put the square there. And then what's the cube root of 8? 2, right? And then 2 squared gives an answer of 4. Now, I know you're sitting there going, well, why'd you do that? I'll tell you why right now. Because now I'm going to give you the second property. That'll be the second part of today. If m and n are positive integers with m over n in lowest terms, okay, now this is probably the most important part of today. A to the m over n power. Now here's the second rule for today. This one is when it was just 1 over something. Now I'm going to give you what the rule is when the numerator is not a 1. It could be some other number. See what I just did here? Now, you see that 2 there? That's like the m. You see the 3 there? That's like the n. See, m over n, 2/3. What did I tell you the denominator was over here? See, this is the whole key to today's class. When you have a fraction for an exponent, what's the denominator telling you? Come on, this is huge for today's understanding. Chris?
The root.
The root. If it's a 2, it's a square root. If it's 3, it's a cube root. If it's 4, it's a fourth root. So, you see the n? This is a to the 1 over n. Where did that numerator end up? The 2. It ended up being the what? Look, it's up there. The 3, the denominator was the root. There's the 1 over n. The 2, where did the 2 show up? It ended up being the what? It's on the board. The 2 in that example up there. Noah.
Exponent.
That's right, the exponent. So this is to the m. Okay, now watch this. Draw an arrow. What's another way to write a to the 1 over n as a radical? I've already given you, but tell me again. A to the 1 over n. What does that mean as a radical? How?
N root A.
Nth root of A to the m, which equals, watch this, the nth root of A to the m. All right, now look, I'm gonna throw the examples up here. The only thing that's gonna be different here now is there's gonna be numbers on the top also, not just the bottom. So here, 36 to the 3/2. Now just put these across in your notebook. 125 to the 2/3. -4 to the 5/2. -27 to the 2/3. -100. Just space these out, because this is what your homework's going to look like. To the 3/2. Okay, that's all I have left. Just look at all them little problems. And let me just simplify what that means over there. When you have a fraction like that as an exponent, what is that property over there telling you you do first? Look right here. What does this tell you down here? You have this. What is it telling you to do first in that parenthesis? The what? Joe?
The root.
The root. The root. The denominator is always the root. So this is the nth root of A, and then whatever that answer is, what's the numerator telling you? It's the whole key to today's class. The numerator is telling you the, someone just said it 2 minutes ago. The numerator is telling you the, what exponent to raise it to. So let me show you this now. 36 to the 3/2. You can give me that answer without doing anything. You can do it in your head. And here's your logic. Pay attention. Pay attention. 36 to the 3/2 means you take the square root of 36 and then you cube it. That's what a fractional exponent means. So 36 to the 3/2 means square root of 36 is 6, cube 6, that's the answer. Somebody? 36 to the 3/2 means square root of 36. You always do the denominator first, that's the root. Then you just raise it to the exponent on the top. What's the matter? You know what the square root of 36 is. 36 to the 3/2 means the square root of 36, which is 6, cube it. What's the answer? Ethan?
216.
Question? These problems are going to get more involved tomorrow. All I'm doing today is giving you the introduction to fractional exponents. That's all. Look at this. 125 to the 2/3. What does that mean? Take the cube root of 125 and then square it. These aren't that hard. You just got to know what the definition means. Andrew, the cube root of 125 is, by the way, now, fellas, you got to know your perfect roots. Are you hearing me? You got to know your perfect squares and your perfect cube roots and some fourth roots or fifth roots like I had on the board there a few minutes ago. So the cube root of 125 is 5 and 5 squared is 25. That's done. Be careful on this next one. I'm not going to say anything. Be careful. Look at how I wrote it. Careful. Because I've already talked about it. See, that would be a problem where a lot of people get careless and they miss it on a test. What do you think the answer to that is? Let me hear what you say here. Burgotts. Huh? No. Pay attention. Please, make sure you get this. I want you to think a few minutes ago, look, remember when I did this, and then I did this? That answer is -4. But when it was grouped like this, that's no real root. There's no parentheses around that -4. Somewhat? Mike?
-33.
Watch this. You see that negative sign? You're not even doing anything with it yet. Exponents first, there's no parentheses. 4 to the 5 halves means the square root of 4 is 2. 2 to the 5th is 32, and then the opposite of 32, and he was correct, what he said. And that's negative 32. Okay, look at the next one. Let me ask you this, so you don't screw this up. Can you ever have no real root when it's an odd root?
No.
No. Are you hearing that? If it's an odd root, you'll never say no real root. The only time no real root can come up is if it's an even root of something. What's negative 27 to the 2/3? What does that mean? It means take the cube root of negative 27 and then square it. Jack, positive 9. The cube root, look fellas, if I wrote it out, look. Isn't that what that means? I mean, that's what I'm giving you there. This means the cube root of negative 27, which is negative 3, and you square that and you get positive 9. What's this? What's this? Alex? This is no real root, because there's parentheses. Square root of negative 100, can't do that in a set of rows. No real root. Okay, now go to your textbook, please.